Hello, hi to everyone. So, this is the engineering section and it's combining open pit designs. I covered oil sand, but this is equally applicable to all mining sector, even if it's a hard rock. So, this is the second one in our designing. The first one I have covered the geotechnical analysis, and now is the hydrologic concentration slash analysis. Geo mean earth, hydro mean water, and logic or logi means study. So the study of water on earth's surface or below the earth's surface. Underground water table. So number one, what we cover in the analysis of this for our open pit design, the first of all we have to know about the underground water table, and the second one the groundwater surrounding the open pit. We are going to open the pit or do the mining. So how much it can affect the slope stability and operation. So these are the two things. The underground water table, as we know, when it's raining, it's come down to the earth's surface, and then the rivers and the river goes to the seas, and then there is evaporation, and it goes again to the clouds and then come back. So it's a water cycle, and we all knows that our surface are not the same. Somewhere we saw the hills and mountains and hard rocks and igneous rocks, sedimentary rocks and metamorphic rocks. So the water percolate on the earth's surface and it goes below the earth's surface and just get their location somewhere, which we call underground water table. Okay, it's another topic. So two methods are used in our open pit design where we can control the water. So what they are: number one, based on the rock formation and the source of groundwater flow pattern. What we can do in this case, when we knew about the rock formation and its permeability and the source of ground of water flow pattern, then we have to lower it or decrease it either by doing tunnels below or at the side of our deposit. It's called it's in hydrology engineering. So that's what we can do. Another thing what we can use a piezometer in the boreholes or in the wells to measure the water pressure, and then we know about the water pressure. So these two methods we can use, and the third one is dewatering. So then we use pumps or give contract to some party who can dewater our pit where we are working. So these are the three methods. What are the major effects of this water? So water pressure basically reduce the shear strength of the two weak surfaces. If there is a two planes, and if there is a silt or some other sediments in between the two surfaces, when the water goes down, so it's decreased and there is a chances of failure and sliding. So the water pressure cause to reduce the shear strength of the surface and reduce the slope stability of our open pit bench wall. The second one is in tension cracks. If someone is tension cracks and fissures, it's a kind of geological terms, but it's a weak zone. And if the water goes inside these tension cracks, so it's reduced the stability and give chance to a sliding. So this is also a dangerous phenomenon. I will give you another lecture later on this. The third one is wedging. Wedging is a phenomenon which is caused by freezing of water within the tension cracks, fissures, fault, and the shear strength to weak surfaces. So it's wedge, and we know that when it goes from 0 degree to -4, so it's it's crack the rock, and there is a chances of failure. So it's called wedging. And the fourth one is drainage, silting, and erosion by groundwater velocity. So the groundwater anywhere in the pits, if it comes out, so it's drain away the silt and it's erode the surface. So sometimes it's block our drainage system. And the fifth one is the dewatering cost. This is the major effect. Then we use pump. And the sixth one is the high moisture content in our ore or waste, which increase the cost per unit of rock when we are taking it to the dumping site or to the plant. So I hope you got the idea about hydrology and what are the effects of water pressure and what are the effects of underground water table on our open pit design. Thank you guys and have a nice day.